You've probably heard that models can use tools now, but there's a real engineering problem hiding under that idea. If you just asked a model in plain English to, quote, use the weather tool, it might phrase that request 100 different ways, and writing code to parse loose, freeform text is painfully brittle. One reworded sentence and your program breaks. Function calling is the mechanism that fixes this, the reliable plumbing that makes tool use actually work in production. Let's dig in. First, let's see the problem that function calling solves. Asking a model in plain text is brittle. Say you want it to fetch the weather. It might reply with a sentence, wrap the request in an explanation, or phrase the arguments differently every time. Your code has to guess where the real instruction is, and any small change in wording quietly breaks the whole thing. This mechanism replaces that guesswork with a contract. Instead of prose, the model emits a clean, machine-readable object naming the function and its arguments. Your code parses it with certainty every time because the shape is fixed and predictable. No fragile text scraping, no hoping the phrasing stays consistent. So how does this actually work under the hood? It's a flow with 4 moves, and each piece has a clear job. Follow it one at a time. It starts with schemas. You give the model a set of function definitions, each with a name, a description of what it does, and a typed list of parameters, often written as JSON schema. This is the menu the model gets to choose from, and the descriptions are how it knows which one to pick. When a model wants one, it doesn't write a sentence. It emits a structured call, the function's name plus the arguments filled in as valid JSON that matches your schema. Clean, typed, and machine-readable by design, not freeform prose. Because it's trained or constrained to fit the schema, the shape is predictable rather than something you have to hope for. Now your code takes over. It parses that object with confidence, validates the arguments against the schema, and runs the actual function, the real API call, the real database query. Nothing executes until your application decides to run it, which is the key safety boundary. Finally, the function's result goes back to the model. It reads that output and continues its response grounded in a real answer. And because the format is structured, the model can even request several calls at once, and you handle them cleanly. Strip it down, and 3 ideas capture function calling. First, instead of writing prose, the model emits a structured request, a named function with its arguments filled in as valid JSON. It's a machine-readable object, not a sentence you have to interpret. Second, this is what makes tool use reliable enough for production. The structured format removes the guesswork of parsing text. The model is trained to fill arguments that match your schema, and it can even request multiple calls at once. Third, and this is the crucial part, the model does not execute anything. It only produces the request. Your application decides whether and how to run it, which is your central control and safety boundary. Good schemas and clear descriptions are what make the model choose correctly. All right, let's lock in the essentials. At its core, function calling is the mechanism behind tool use, where model outputs a structured request naming a function and its arguments so your code can execute reliably. It works through a contract. You define function schemas with type parameters. The model emits a valid JSON call, your code parses and runs it, and the result goes back to the model. It matters because that structure is what makes agents and tool use reliable enough for real production, removing the brittle guesswork of parsing freeform text and the retry loops that come with malformed output. And crucially, the model only produces the request while your code decides whether to run it, so clear schemas and validation are everything. If untangling AI like this is your thing, we've got much more of it over at Standarity.com. Come explore.